Hey guys, and thank you so much for joining me for this session. And today we are going to talk about how to break into APIs. We'll talk about modern techniques to break into modern applications that are based on APIs. So the agenda for today is, first of all, before we even talk about application security and about how you can leverage APIs to hack into applications, basically to understand what is modern application security and how it's different than traditional application security. After we talk about it, we will cover some of the OWASP top 10 for APIs with emphasis of how to leverage these issues as a pen tester and how you can use the OWASP top 10 for APIs to find core vulnerabilities and to break APIs. And then we'll see some recent examples for API issues that happened in the last few months in large companies. Just a quick background about myself. My name is Inon Shkedy. I'm the head of security research at Traceable AI. This is a startup in the field of cloud native application security. I got 8 years of experience in application security. I performed many pen tests, and I grew up with APIs. What does it mean? Basically, I started my career back in Israel. I was part of the red team of the Israeli government, and it was a fun time. For 5 years, I had a chance to break into many systems in the field of government, military, and financial. As you could imagine, these systems are heavily based on traditional technologies like Java, ASP.NET, SAP, and very traditional concepts, multi-page applications, on-prem environment, waterfall. An API used to be just a niche component, mostly for B2B communication. After 5 years in the Israeli army, I decided to move to California, to the Silicon Valley. And for the last 3 years, I have been working mostly with startups and tier one companies. And I got exposed to a new field of technologies. Instead of Java, SAP.NET, and all of this traditional stuff, I started saying more and more Ruby on Rails, Node.js, Python, Elixir, and more. And the interesting part is that I also got exposed to new concepts like single page applications instead of multi-page applications, cloud environment, CI/CD, and the most important part is all these applications are heavily based on APIs. It's no longer just a niche component for B2B communication. Today is the backbone of the application. So after I moved to the Silicon Valley, one of the first things that I figured out that I can't really use my old ways. Like I could really find SQL injection and cross-site scripting. I had to adapt myself in order to find interesting stuff in APIs. And this is why I am creating this presentation to share with you some of my thoughts and how you can adapt yourself to this new battleground of APIs. So I want to talk in a very high level, like briefly about what has changed between traditional applications and modern applications. So here on the top of the screen, you can see the traffic patterns between the client, web server, and database in the case of traditional applications. In the past, it used to be pretty simple. The client would send an HTTP call to fetch one specific web page, for example, home.jsp, and then the web server would fetch data from the database in order to build the visual component, the visual web page that would be sent back to the client. This process of converting the data into like a visual page is called rendering. So the rendering component was on the web server. And then the web server simply return an HTML page to the client, would be presented to the user by the browser. Today, things look very differently. First of all, the clients know much better what they want. The clients don't ask for a complete web page. They ask for specific pieces of information. For example, if you're looking at the dashboard component of some application, the client would send API calls to fetch the last 20 notification or fetch the top 10 users as part of this app. So clients have much more context of what they need and what they want. And also it's worth to mention that today clients maintain the user state. Back in the day, you had mechanisms on the backend. So the backend knew exactly what is the state of the user, what buttons the user has clicked, what is the specific state of the user. It was done using view states and cookies and other mechanisms. Today in APIs and modern applications, usually the clients maintain this state and the web server has less context of what is happening on the client side. So after the web server gets the calls from the clients, it would fetch data from the database, and you have more types of databases. On top of like the traditional SQL, you can find today Elastic and NoSQL, and many more other types of databases. And then another interesting change, instead of returning HTML pages, today the web server, the API, returns raw data in the format of JSON. So the client would just receive raw data, and all the rendering process, the creation of the visual page would be done on the client itself. This is a very interesting change. A few other changes is, first of all, you have more types of clients. On top of the traditional web servers, you can find IoT devices, mobile devices, and sometimes even other developers that use your APIs to develop their own applications. The second point, which is very interesting, I had this claim many times that APIs have less abstraction layers. It has many different aspects. There is no one concept that supports this, claim. But one important concept is that APIs today, the clients, the APIs, and the servers, they speak the same language. All of them speak in JSON. For example, the receipt object that your Uber client is processing on your mobile device might be the same JSON object on the API, and sometimes even on the databases. So there is much less parsing when it comes to like objects that are sent from the client, because all of them speak the same language. In terms of application security, it was to mention that many of the traditional web application vulnerabilities are being solved today. For example, if we talk about SQL injections, many of them are solved by the use of ORM environments by developers. If we talk about CSRF, today it's much less common because developers move from cookies to authorization header. If your authentication mechanism is not based on cookies, you are not vulnerable to CSRF by design. Cross-site scripting, today it's the responsibility of the client to protect you against cross-site scripting. APIs return raw data in the format of JSON. They don't return any HTML pages. So this is why it's the responsibility of the client. If we talked about XXC, for example, which is a vulnerability in the parsing process of XMLs, today it's less common because developers use JSONs and they don't really parse XMLs. Let's move to the bad news. So the first point about APIs, many times when I see REST APIs that is exposed by a company that I'm performing a pen test to, I get very excited. APIs today are a very attractive target for attackers. And there are many reasons, but I think that the main ones are, first of all, the attack surface is much larger. APIs expose more endpoints, and APIs receive more parameters. In order to support the same component, for example, in the case of the dashboard component, in the case of traditional applications, you would see only one entry point to get dashboard. In the case of modern applications, you might see 5 different endpoints that are being used to populate data for the same exact component. And the second point is APIs are oversharing. You can take a look at the traffic between the clients and the API and to understand the underlying implementation of the application. And the third point is that APIs are much more predictable. The REST standard and the GraphQL standard encourage developers to develop APIs in a very predictable way. It's very convenient for the front-end engineers to use these APIs, but it also makes attackers' life much easier to guess sensitive API endpoints, for example, admin endpoints. So all of these changes that I've seen made me join Elon and to start the OWASP Top 10 for APIs project, and in general, the OWASP API security project. We tried to define this modern battleground. It was a very interesting process to create this list. We collected a lot of data from bug bounties programs, and then we came up with the final list of the OWASP Top 10. And we also got a bunch of feedback from the community to prioritize and to add new vulnerabilities. So I want to talk with you about API pen testing. This is the main goal of the presentation, to give you some ideas and some tips how to perform a better API pen testing. So it's not only a bunch of tips, it's also like I'm going to talk about the required mindset in order to hack APIs. Let's talk about some of these concepts. First of all, in my opinion, there are two types of pen tests. The first type is more straightforward. You just try to break into an application. You generate payloads. You try to like exploit SQL injection and stuff like that. Sometimes you get vulnerability, sometimes you don't. This is like the most simple approach to perform a pen test. And then the second approach is to get into the developer mind. Like I think every experienced pen tester will tell you that if you want to exploit and to find core vulnerabilities in the application that you are testing, you need to understand what happens on the backend. Even if we talk about black box and you don't have access to the code, you should aspire to understand what happens on the backend. So how can you read developers' minds to understand what they wrote on the code? So there are a few things that you can do. The first one, you should think like a developer. And in order to do it, it's really helpful to know how to code. I think that every good pen tester that wants to find business logic vulnerabilities needs to understand code. You don't need to be the best developer. I promise you, I'm not a great developer. I don't know all the design patterns, and I usually don't leave a lot of comments in my code, but I do understand code, and I do know how to code simple scripts. And I think it's very important for you as a pen tester to do it if you want to find cool stuff. And the third point is to understand the DNA of the app. The DNA of the app would allow you to understand better the business logic of the app. And it's very important to understand that today, when we talk about API vulnerabilities, many of them are based on business logic abuse of the application. So in order to abuse the business logic, you need to understand the business logic. So as I told you, about 3 years ago, I moved to California, and one of the coolest concepts that I found, one of the coolest things I found after I moved is mindfulness. Mindfulness makes you a better person, but it also can make you a better pen tester. So there are many concepts from mindfulness that you can leverage in APIs pen testing. First of all, is beginner's mind. Beginner's mind is a concept that tells you that you need to be curious about anything in life. So the same thing about APIs. You should understand what is the business logic of the application by looking at the API traffic. And many times, I know that pen testers, if they see API endpoints they don't understand, they just ignore it, or they just assume that it's not important. This is not a good approach when it comes to pen testing for APIs. Every time that you see an API endpoint, you should understand at least what is the purpose of the API endpoint and to ask meaningful questions. What is the feature that caused this API call to trigger? And stuff like that. And the second point, you should wean yourself of GUI. Many times when you perform a pen test for APIs, you don't have a client, or the client doesn't access all the features. And you have only documentation for the API. You shouldn't let fear stop you from generating API calls from scratch. Just to start understanding how you can call an API endpoint without having an active client. So do you know what all these companies have in common? Uber, Facebook, and Shopify, they all got breached in the last year because of access control problems. It leads me to the point that authorization problems is the biggest threat of APIs. Every company has authorization problems. So most of the API vulnerabilities are somehow related to authorization. And I want to spend some time talking about it. So the most common API vulnerability, BOLA, it's broken object level authorization. You probably know this vulnerability is IDOR, insecure direct object reference. It's basically a vulnerability that allows you to access IDs that belong to other users. In this case, I'm trying to download a document. My client would send an API call to download file number 113, which is legit because this is a file that belongs to me. But then I just change the ID from 113 to 114, and I access a file of a different user. Number 3, excessive data exposure. It's another type of authorization problem. This happens because the developers return too much information to the user. So the client just returned too much information. And number 5, broken function level authorization. These are API endpoints that should be accessed only by admins or privileged users, but the developers don't check if the user that called the API endpoint is actually an admin. I want to talk about the DNA of modern applications. Those are the building blocks of the business logic. And if you want to have a more comprehensive pentest, you need to understand them. You need to understand them like in a mental way, just to understand them in your mind, or sometimes it's also helpful to write down and to create some diagrams when you perform pentests to understand what are the components. Let's talk about some of this DNA, some of these building blocks of APIs. So if we take, for example, the Uber application, you have different types of users and roles. You have riders, drivers, and admins. And you need to understand what are the different clients of Uber. You have a mobile, which is obvious. You have like Android and iOS. Then you have the web application. I'm not sure if you know, but you can access Uber also using the web application, which is a different API. And you also have IoT. So in the case of Uber, you have e-scooters, for example, or the jump bikes. They communicate with the Uber API using a different API. And then you need to understand what are the different APIs behind the scenes and the resources. In the case of Uber, the resources would be the receipts, the trips, the users, and scooters, for example. If you understand this full picture, it would be much easier for you to understand the business logic and to expand the attack surface. So let's talk about broken object level authorization, which is IDOR, and how we can exploit it. And more than that, how we can leverage the DNA of the application in order to perform better exploitation and to find more potentially vulnerable endpoints. So let's say that you upload a photo to the application. You have a feature of uploading a photo, and then you see that if you want to access this photo, there is an API call to get/editor API/v1/photos/717. So if we translate it to business logic, you can tell yourself that there is a resource that is exposed through an API to me. Let's try to see what are these components. So a resource is a photo, and then the API is the editor API. You can see it in the URL. And me, who is me? I am the user Bob, which is the user ID of 8581. I'm a regular user, and I'm accessing this API endpoint using the mobile application. This is an iOS application. So this is, if you translate this API endpoint, like if you just perform a simple pentest, you would just try to change the ID from 717 to 716, and you might get access to a photo of someone else, or just 401, like to get rejected. But let's see how we can leverage this language of the DNA of the API in order to expand attack surface and to find more potential endpoints that are vulnerable to BOLA. So some questions that you should ask yourself regarding the resource, regarding the photo. First of all, is the resource private? Sometimes we can see API endpoints that receive IDs, but if you try to change the ID to something else, you can get access to a different ID. It's not necessarily a vulnerability, because sometimes these resources are public. For example, it's a news article. Everyone should have access to this endpoint. So make sure that you don't send bugs that contain IDOs for resources that are private. The second question you can ask yourself is the resource shareable? Is it possible to share the resource? Sometimes if you have on Facebook, for example, an option to share a photo with someone else, it can lead to another vulnerabilities. And the last question, is the resource encapsulated? What does it mean? So let's say that you try to find BOLA to steal photos of other users, but you can't really find any API endpoint that is vulnerable to BOLA that access photos. The next thing that I would try to do is to find what resources might contain the photo. So in this case, it might be an album. And then you can expand your attack surface. And you should list all the API endpoints that access the resource or the encapsulated resource. Let's see how we can do it. For example, what we can do is to change the editor API/v1 to editor API/v0. This is a different API input that is potentially vulnerable to BOLA. And then if we see that all the endpoints that access photos don't vulnerable to BOLA, let's try to move to the export album to an endpoint that actually access the album behind the scenes. And only if you have the understanding that album contains photos, you can be more focused on this API endpoint that expose the album. And then you can start asking yourself, can I use a different client to access the same resource? Can I use a different, maybe if I access the web application, would it look different? Or if I access the mobile API, it would look different. So many times, if you have web client or a mobile client, the API endpoints that they trigger, the API calls that they trigger belongs to different endpoints. So you might have one endpoint to get photo for mobile and one endpoint to get photo for web. And you should test both of them. So if you map all the endpoints that might be vulnerable to Bola and your goal is to access a photo of someone else, how can you validate that a specific endpoint is vulnerable? So there are a few approaches. Many times what pen testers prefer to do is just to change the ID of 717 to an ID of something else, for example, 716. But there is a better way to do it. So the first step would be to create user number one, to log into the API and to create a photo, and then to access this photo. So you access a photo that belongs to you. This is nothing exciting, but you need to have this API call documented, for example, on Fiddler or Burp. And then what you do is create a different user, and you copy the session label of this user. After you log in to this user B that you just created, you need to copy the session label. A session label, what is a session label? Is basically every string that is used by the API to identify a user. It can be authentication token, it can be a session ID, it can be everything else. It doesn't really matter. You just need to copy this single string that is used by the API to identify the user and to duplicate the first request to access photo 717 and to replace the session label. And after you do it, if you get access to the photo, it means that the second user could have gotten access to the photo and it's vulnerable to Bola. If you got some authorization error like 401 or 403, it's probably not vulnerable. Some random tricks to exploit Bola. Sometimes you can see that companies have implemented authorization mechanisms, but it's still possible to bypass them. Some ways to do it is, first of all, you can try to wrap the ID with an array. Sometimes the input filtering or the authorization checks are done only for integers, but not for arrays that contain integers. You can try to send the URL, the ID twice in the URL. For example, in this API endpoint, the first ID would be the legit, and then the second one would be the victim's ID. This approach might work because in some cases, as you can see in the diagram below, the authorization mechanism is implemented on one microservice. This is very common in modern applications, that the authorization mechanism is in one microservice. This microservice might run like a framework of Ruby on Rails. And Ruby on Rails uses a specific library to parse JSONs or to parse URLs. And in this case, this library of Ruby on Rails might consider the first ID. But then the API endpoint itself that actually fetches the data from the, this is after the authorization. You're already allowed to access this endpoint. So maybe the logic to fetch the data is using a different library because it's a different microservice, it's a different framework, for example, Django. And then this framework considers the second ID. Other random tricks, if you see an ID in the URL, try to move it to the request body. If you see an ID in the request body, try to move it to the URL. Sometimes it works. If you see a GUID, try to send a numeric value as well, like integer. If you see like a random long GUID, just try to send like 5 or 6. Sometimes companies have support for both of them, and they implement different mechanisms to protect against Bola for GUID and ID. One tip that I can give you, one of the best tips that I can give you, that can make your life easier. Try to focus on IDs in the body. They tend to be more vulnerable than IDs in the URL or in the query parameters. Let's talk about excessive data exposure, how we can exploit this vulnerability. So excessive data exposure is one of my favorite vulnerabilities. Instead of performing a complex pen test, APIs just leak PII by design. Let's see how it looks like behind the scenes. You have Bob, you use some dating app, and then you see the profile of Bob, and you see only the public data about Bob, like name and hobbies. But behind the scenes, you can see an API call to get/user/717, and the API response contains all the public data, like name, profile picture, but you can also find the address of Bob, which is PII. What happens many times, developers on the backend, they rely on the developers on the front end to filter out the sensitive data. This is a very bad idea. Maybe you cannot see it as a user because the developer actually filter out this data before presenting it to the UI. But if you sniff the API traffic, you can easily expose this information. So it's a good question how to exploit this vulnerability in APIs, because it's not very straightforward. You just need to call all the API endpoints and to start taking a look at the responses. So some tips that I can give you how to navigate this maze would be to understand the hierarchies between users, roles, and resources. Let's say, for example, that you access this API call to get your previous rights. From this response, you can understand that you have the resource of rights, that inside it has a nested resource of driver, and then the nested resource of driver has a resource of car. So the ride here does not contain PII, right? Or PII or any other type of sensitive data. Because when we talk about sensitive data exposure, the goal here is for us as a pen tester, is to find sensitive data. So we see that also the driver does not contain PII, but the car resource actually contains the VIN of the vehicle, which is PII. This is a unique identifier of a vehicle. It shouldn't be exposed. So let's say that now your goal is to find details about the driver. So what you should do is to find all the endpoints that expose the driver resource. So what you should do is to find more endpoints that actually access this information. And maybe because it's a different endpoints, there is different code in the backend that is running. And maybe the developers made a mistake and returned too much information. Like in this case, if you have an option to export rights to a CVS file, you can see that the response from this API call contains sensitive data about the information. So you found an API endpoint that exposes PII of a driver. And then you want to move in even further and to find more information about the driver. So you go and you find a different endpoint that accesses in some way. Like basically, it's a game of understanding which endpoints access which resources. So you're trying to find endpoints that access the driver resource, right? So you say, okay, I have an option to report a complaint about the driver that did something illegal on the road. So you access the web application to report driver, and you send a complaint. And you hope to see in the response some sensitive details about the driver, but you don't find anything. You see just the name is John, which is not interesting. But what happens if you replace web to mobile and you report the driver? You might be able to access the address of the driver. And then you might access, you might find a driver account, and you want to register your car, right? Just as part of like creating a new user as a driver. So what you can try to do here is to register a car and to put the VIN of a different car that you already have from the previous endpoint. This is a VIN that belongs to a different driver. And then the response actually says this VIN is assigned to a car, and you get the GUID of a different car. And if you access, and then you keep looking at the app as a driver, and you see an API endpoint to fetch the details of your car, v2/car details, and the ID of the car. So you can use the ID of the car that we got from the previous API endpoint to access details about another car that belongs to a different user. But the response does not contain interesting information, so we can try to change it to like maybe v3. And this is a good tip. Many times the implementation of v2 and v1 and v3 are different. And you can see that v3 of car details actually exposes the whole object of the user, of the driver. So this is a way to get PII, like the full name, the last login, and even the reset password token. This is a full account takeover, and this is based on a real example. So this is like the mindset. I know it might be a bit complex, but this is the mindset that is required to find this type of vulnerability. We need to find all the endpoints to expose the resource that you potentially want to exploit, or you want to find excessive data exposure. So it's more about finding more endpoints than like, sending different payloads. So let's talk about API predictability. APIs are very predictable, and we can leverage this fact as pen testers in order to do interesting stuff. The first one, how can we leverage the predictable nature of REST APIs to find admin endpoints? So in the case of traditional applications, it was very hard to find admin endpoints. Why? Because you had to guess all this endpoint of /app/admin panel/user management.aspx, and you need to mention the action and the user ID. And this is an endpoint that's exposed only to admins. Even if the developers did not check that your user belongs to the admin group, it would be hard for you as a pen tester to find the endpoint. Fortunately, in APIs, it becomes much more simple. APIs are very clear. Many times, if you want to find admin endpoints, you can just change the HTTP method. So let's say that you use the app as a regular user, and you see an API call to get/API/user/user ID. You just change the get to delete, and you find an admin endpoint to delete a user. So you found the path to the endpoint. And in many cases, developers don't really validate that you belong to the admin group, and you can access admin functions. How can we leverage the predictable nature of REST APIs to find hidden features? So, many times the API whispers secrets. If you saw this API call, this is some ride-sharing app, this is Uber, and then the response contains payment option. But you paid only using one credit card. But as you can see, the response contains the ID of your credit card inside an array. The first thing I would try to do if I saw this API response is to try to find the payment splitting option. Because if there is an array in the response, there is a reason for it. There is probably some option to split the payment, and it might be a very interesting feature. One of the best things that I can give you, if you perform a pen test for applications, especially APIs, don't focus on the main API endpoints. If you have, in Facebook, the main API endpoints would be to upload a photo or to leave a comment. These endpoints, probably the developers that wrote them probably invested more time thinking about security, and probably they already had some like security assessment. So your goal as a pen tester is to find the most niche features. For example, if you have an option to add Christmas greeting to your profile, this is something that exposed only for a couple of weeks during the year, and nobody actually uses it. So this much more likely to be vulnerable to vulnerabilities than like the main endpoints. Or for example, if you have an option to connect MySpace account, probably developers, put less effort to secure this API endpoint because nobody uses MySpace today. And the way to find these hidden endpoints, or like the snitch endpoints, is to look for URLs in JavaScript, APK, and IPA files. And also, it's very important to dig deep into the UI in order to find all of these features. Because every time you find like a new feature, like a new button that like it takes time to find this button. Behind the scenes, there is an interesting API call. It is triggered to a niche API endpoint. How can you leverage the predictable nature of REST APIs to find hidden versions? So, for example, if you want to find SOAP API, you can just take the API call to all trips with the content type of application/JSON, duplicate the API call, and to change it to application/XML. And you might be able to find a SOAP API. And many times, if you have SOAP APIs and REST APIs and GraphQL, don't assume that all of these APIs, like different protocols, they usually don't implement the same security mechanisms. So even if you found rate limiting when it comes to REST APIs, probably the SOAP APIs don't have it because it's different configuration, and many times they're more exposed. To find all the endpoints, you just can change the v3 to v1 and might be able to find a different endpoint. This is pretty simple, but it's very helpful to expand attack surface this way. You can find this presentation these slides I'll share with you. And a few more resources that might be helpful for you to perform a more successful pen test for APIs is the OWASP top 10 for APIs. And I also post a lot of tips on my personal Twitter account and Medium about API security. I hope you enjoyed the presentation, and let me know if you have any questions. Also, feel free to ping me on Twitter and LinkedIn. I'm always happy to discuss API security. Thank you, guys.